Yes, we are here again. We are here again to continue with the grinding. So let's continue with S3, AWS S3, access control. Let's continue. Let's go. Actually, let's go with this time. Let's do it like this. Let's go with Pytorch. Let's go with Pytorch. Then let's go with Django and React. Then let's go with AWS at the end. All right. I agree. Today is a nice day. It's raining, but it's great. It is great. In fact, no. Okay. Let's do AWS, React, Django, AWS. I have not enough space. Okay. Let's start brand new here. Okay. So we are going to talk about here about Pytorch. Oops. Okay, this looks cool. Let's go over. What is this? Why I'm saying this? Google News. I don't want to see anything of this. Recent tabs. Where is the home? Team homepage. No, I don't want a homepage. Okay. Still, I'm having the same thing. Okay, that's okay. Let's find some Pytorch samples. Let's look for YouTube. Let's see. Then let's use this Pytorch. Okay, what we can see by just looking Pytorch.
Hosting WordPress administrado por Hostinger. Estas son 3 herramientas para mejorar.
Pytorch, an open-source deep learning framework used to build some of the world's most famous artificial intelligence products. It was created at the Meta AI Research Lab in 2016, but is actually derived from the Lua-based Torch library that dates back to 2002. Fundamentally, it's a library for programming with tensors, which are basically just multidimensional arrays that represent data and parameters in deep neural networks. Sounds complicated, but its focus on usability will have you training machine learning models with just a few lines of Python. In addition, it facilitates high high-performance parallel computing on a GPU thanks to NVIDIA's CUDA platform. Developers love prototyping with it because it supports a dynamic computation graph, allowing models to be optimized at runtime. It does this by constructing a directed acyclic graph consisting of functions that keeps track of all the executed operations on the tensors, allowing you to change the shape, size, and operations after every iteration if needed. Pytorch has been used to train models for computer vision AI like Tesla Autopilot, image generators like Stable Diffusion, and speech recognition models like OpenAI Whisper, just to name a few. To get started, install Pytorch and optionally CUDA if you want to accelerate computing on your GPU. Now import it into a Python file or notebook. Like I mentioned, a tensor is similar to a multidimensional array. Create a 2D array or matrix with Python, then use Torch to convert it into a tensor. Now we can run all kinds of computations on it, like we might convert all these integers into random floating points. We can also perform linear algebra by taking multiple tensors and multiplying them together. What you came here to do, though, is build a deep neural network, like an image classifier. To handle that, we can define a new class that inherits from the neural network module class. Inside the constructor, we can build it out layer by layer. The flattened layer will take a multi-dimensional input, like an image, and convert it to one dimension. From there, sequential is used to create a container of layers that the data will flow through. Each layer has multiple nodes, where each node is like its own mini statistical model. As each data point flows through it, it'll try to guess the output and gradually update a mapping of weights to determine the importance of a given variable. Linear is a fully connected layer that takes the flattened 28 by 28 image and transforms it to an output of 512. This layer is followed by a nonlinear activation function. When activated, it means that feature might be important and outputs the node, otherwise it just outputs 0. And finally, we finish with a fully connected layer that outputs the 10 labels the model is trying to predict. With these pieces in place, the next step is to define a forward.
What else can be useful here? The stat quest. Deep learning for beginners. Build your first Pytorch model in minutes.
In this video, I'm going to show you how to train your
how
very
to do that
first
then.
Pytorch model. If you're interested in
I'm
deep
sorry,
learning,
need
you
to
really
accelerate
have
this to understand
but in recent
quickly
years,
because I
Pytorch
don't
has
have
really
enough
exploded as
time.
being the front runner, and the main reason is because of its flexibility. Years, I've trained thousands, if not tens of thousands. We're going to actually start. This knowledge will create that has a GPU. I'm have the GPU with CUDA installed and Pytorch in the correct Pytorch.
Yeah, now CUDA has to be installed. Library, yeah.
We can see some information about this environment.
Fair enough. Straightforward to do it.
And the GPU is going to be critical in speeding up.
I have a GPU. I have already a computer with CUDA installed. So what's going to be next?
We can see the way the data is set up. There's a training folder, and in each of these, we have a folder for different cards and a playing card deck. If I click on each of these images, you can see the playing card images show
My
here at the
training
bottom.
folder
So this is the
for the
type of data
name.
that we're working with. And this is where we're going to learn through doing. What we're trying to achieve is create a model that is capable of taking in images and then detecting which playing card is in that image. And we're going to break this down.
Okay, how to train.
And that's understanding
So the
Pytorch
data set.
and data loaders and how that works. Learning how we set up the Pytorch model module. And then
We have data set. We have to
now, these 3 steps are critical to
preprocess the
any
data
Pytorch
set.
model. It doesn't have to be an image classifier. It could be for object detection.
Then train the model
Follow this idea. All right, so the first
in
thing
a
we need
loop.
to do is import all the packages we're going to be using for in this tutorial. So obviously,
Pandas,
we're going to import Pytorch,
NumPy,
import the NN module from Torch. This is all the specific functions
neural
related to neural
network,
networks. We're also going to import the
NN,
Optim library, which will define our
package,
optimizer layer. Data sets and data
Pandas,
loader will be the very
NumPy.
first step in the process. We need to import them. And we're also going to import
Seems to be pretty
working with these image files a lot easier. TIM is a great library for loading in architecture specific for image classifications. We'll import that. And then, like always, I usually import Matplotlib for visualization, Pandas, and NumPy because we need to use those for data exploration. I like putting all the versions out here. So if you're running this layer, you can compare to what version that you're running, and there may be some slight changes. We are running Pytorch 2, and we're running Python version 3.10. The first thing you're going to need to do to train a Pytorch model is to set up the data set, because that is how Pytorch is going to be loading in the data as it trains the model and evaluates the model. Now, the nice thing about Pytorch data sets is they're extremely flexible. You can really modify them to load the data in whatever way you want, and then you can take that data set and just wrap it with a Pytorch data loader to make it parallelized and load in the data batches for the model. And we create this data set by simply creating a Python class. In our class, we're going to call playing card data set. This will inherit from Pytorch.
Okay, the data set is going to be created, so what?
Now, if you're not that familiar with using classes in Python, you might want to do a read. And in Pytorch datasets, we'll need this method called this, and we'll also initialize with the transiches to the same size, which will take our data directory and what folder have name is called data. And we can see
so you're loading the data
set, item method by calling this data set on one of these index locations. It should work anywhere between 0 and the max length of this. You can see when we call this at various in here in this data set, it's not going to display here because it's a Pytorch to work with them, but we don't know which number is associated.
You build a kind of a dictionary.
And that's where we're going to use
You transform,
from Torch Vision. And we're keeping this transform as simple
prepare the tensors. Okay, process the data, prepare the model, the transformer.
With this transform added, tensor to get an idea of the the size of panels. That's a red
then via tensors, obviously, which is a data structure.
We'll just have it break out of this after the first time we run it here.
You do it for all the assets, all the images, or files that are gonna be trained.
The main ones we're gonna focus on are batch that are able to the data.
Wait, well, yeah, you already loaded, you created the tensors, and then you are going to process the data. You're finally doing that here. And then once you have the data pre-processed, and you have the TensorFlows, I mean the tensors, then you create the model. And specify the model properties. The network, the neural network model. And then you start iterating one by one. This data into our model many times, and then we're going to apply some sort of loss function to the outputs that we receive. You start running the backward and step, calculate the loss function. You're basically training the model in this phase, and it has to be in a loop. You can see this works correctly with the input data that we have. Our data set actually, I've set up our data screen size each in the data loader show. Any data set. So you have at the end the training, the valid, the test folders. Using our criterion, which we defined above, in each of these steps, our running loss. First, compute that by taking our running loss and with our training loss. We need to make sure we pull are not touched is to do this model training loop, and we're just going to put a few names here. And if I run this set being done on this instant way, it's going to compute for CPU and or do this by taking the model and telling it what? And at the end, you should test the model to see if it's working or not. Now what we need to do is just wait and let them up the notebook. But as this runs, we hear you're loading it. You're in the training loop. We did have a strange spike here in the validation, a little bit longer. Get familiar with Pytorch data from the model. And you finally evaluate. You run a test image, you have an output for probabilities with a probability answer. Yes. Pretty. Okay, nothing crazy. Okay, do we have any kind of documentation same as AWS? Same as AWS. Learning Pytorch with examples. Introduction to Pytorch, okay. Learning Pytorch, image and video, audio, backends, reinforcement learning, deploying Pytorch models in production, profiling, code transformation, front-end API, extending Pytorch, model optimization, parallel and distributed training. That's really amazing to know. Edge with PyTorch, recommendation system, multimodality. Okay, let's go. But we have PyTorch recipes. What is this? Nothing. There's nothing there. So learn the basics. We are there. So let's go with the basics. Let's close this up. Cool. Created on February 2021. Last updated 2024 November, last year. 4 months ago. Oh, no. Ouch. I need to increase the font size. Saved. Well, where are you? No. Okay, let's go. Okay, let's go. Let's run this. Most machine learning workflows involve working with data, yes, creating optimizing models, model parameters, parameters is important, and saving the training models. This tutorial introduces you to complete machine learning workflow implemented with Pytorch, with links to learn more about each of these concepts. We'll use fashion M and East dataset to train a neural network that predicts if an input image belongs to one of the following classes. Okay, it's gonna categorize clothing images: t-shirt, trouser, pullover, dress, coat, sandal, shirt, sneaker, bag, or ankle boots. So how to start this? How to use this guide? I guess reading. Next. Quick start, working with data. Pytorch has two primitives to work with data. Data loader. Okay, let's first read this. As part of the basics we are going to cover quick start, yes, some model concepts there, tensors, datasets, and data loaders. Tensors, datasets, data loaders, transforms, build a neural network, automatic differentiation with Torch autograd, optimizing model parameters, save and load the model. Okay, that's the basics. Okay, basics again. Tensors, datasets, data loaders, tensors, datasets, data loaders, transforms, tensors, datasets, data loaders. Okay, tensors, datasets, data loaders. So basically with tensor we are going to have that data structure that's going to be used to do things with datasets and data loaders. Then transforms, we need transformers. Tensors, datasets, data loaders, transformers, and then we have the neural network model, and I don't know what is this Torch autograd that's needed as well. Then we optimize, we fine-tune the model parameters. So we gotta use the best parameters for the model to be trained, which I guess that's the training phase. Save and load the model. So let's validate a little bit this with Pytorch. I mean, Cloud AI. Do I need to? Okay, let's just ask like that. Learn Pytorch by reading documentation. So understands some comments, some of it, some concepts, parts of it, and concepts. Explain what is the workflow to create a model using Pytorch. From top to bottom. So teach me, explain what's needed to create a model. Set up and import. Okay, I'm seeing the code. I mean, you needed to say Like first turn on your computer, then take a seat. Okay, we need to import libraries. Yeah. Data preparation. Okay. Model definition. Okay, where are the tensors here? Okay, the model is the neural network model. I guess it's coming. Loss function and optimizer. The loss function and optimizer. The training loop and evaluation and saving and loading. Inference. So pretty much okay. What the fuck? Where is the tensor definition? What else? Data sets and data loaders. Transformers. Give a high level overview of the workflow. Oh, you're right. I should start with the higher level overview and include the foundational elements. Let me provide a clearer picture of the Pytorch workflow. Okay. We have tensors, but okay. Are we starting right away with tensors? It seems like so. Data management. Model definition, then loss function and optimization, then training loop, then evaluation and inference, then model persistence. So first we need the data, we need to pre-process, load the model, prepare loss and optimization, evaluation and deployment. I'm really confused, bros. I'm really confused. Okay, let's see how this works then. Pytorch has two primitives to work with data. Data loader and dataset. Dataset stores the sample and the corresponding labels, and data loader wraps an iterable around the dataset. So dataset, data loader. Pytorch offers domain-specific libraries like Torch Text, Torch Vision, Torch Audio, all of which includes datasets. For this tutorial, we will be using a Torch Vision dataset JAX. We are using images. The Torch Vision dataset module contains dataset objects for many real-world vision data like CFR, COCO. Dataset includes two arguments, transform and target transform, to modify the samples and labels respectively. Okay. Download the training data from open datasets. Data. So we have the training data here. We're just getting this. The datasets and the test datasets. Okay, let's kind of take note here. Talking about the basics, working with data. Okay, data. Then creating model optimizing, saving. Sure, yeah, let's read this all. Let's take notes at the end. It's pretty short. Okay, we download the data. We got the data sets and the training data. We got the training data and the test data. Okay, clear. Then what? So That's basically data set. Get training data, get test data. Then what? We have to load, we have to load the data using data loaders. Both of them, the training data and the test data. Okay, what's then? Once we have the data ready to use with data loaders and data sets, in parallel or after that, we can create the models using the neural network library or package, whatever it is. We can opt to use GPU or else we can use CPU. So with a conditional, we can define that with torch condition torch.accelerator.is available current accelerator. Okay. We define the model using the NN package. We inherit from that model. We specify this thing, I don't know what is. Linear relu stack. Rectifier something was this. Then we define the forward method. We basically define the model we are going to use. We got the data prepared, we got the model prepared. Now what next? We optimize the model parameters. Okay, what parameters we are going to use and how to optimize them. How to optimize them. In order to optimize the model, we need the loss function and the optimizer. So yeah, we're putting things into place. Optimizing model means loss function and the optimizer. We define that with some parameters in place that can be specific per each case, I guess. Right now we are using the Torch Vision library. In a single training loop, the model makes predictions on the training data set. In a single training loop, the model makes predictions on the training data set. Fed to it in batches. And backpropagates the prediction error to adjust the model's parameters. So it will fine-tune itself by itself. I just need to watch and wait and watch. And that's the training. So it's created a training method here. We also have the test method. And then we save the model. So both of them. Optimizing model parameters mean we start to train already and we let the backpropagation make the self-optimization of the model can take place by itself. Okay, so what? Yeah, that's what I understand. So what we have here? Train. We specify the model, we specify the data loader, we specify the loss function and the optimizer. So we load the data, we call the train function from the model, and we iterate the data in the data loader. We load that to the GPU device. We compute the error, we predict the error by using the model and the loss function, and we backpropagate the result of the error, if any. Well, that's gonna be based on errors. And the optimizer has to optimize it. Then once we are done with the data, we compute some things that I don't get here. Well, once that's done, the training is done. we can test the model's performance against the test data to ensure it is learning. So what does it mean? Shouldn't be once it's done we can run the test. Okay. Same for the test, not the training, the test. We use the data loader, we pass the model, we pass the last function, we load the data and define the batches. We run the model evaluation. We use Torch, no grad, I don't know what it is. We load the data in batches to GPU device. We run some compute stuff. Correct. Our prediction type, torch floats, test losses, number of batches, correct size. Okay. The training process is conducted over several iterations, epochs. During each epoch, the model learns parameters to make better predictions. During each epoch, the model learns parameters to make better predictions. We print the model's accuracy and loss at each epoch. We would like to see the accuracy increase and the loss decrease with every epoch. So this is basically the definition. We define how to train, we define how to test, and we run epochs like cycles. Documentation says, well, tutorial says 5 epochs, 5 cycles, where we pass the training data loader and we pass the training data, the model, the loss function, and the optimizer as part of the training. And then we pass the test data, the model, and the loss function to validate how it's working. Then, so I can see here the 5 epoch results. Accuracy. So what we're printing? We're printing the loss, current, test error, accuracy, 53.9%, average loss 2.16, accuracy 60%, loss 1.92, accuracy 61%, loss 1.54, accuracy 62%, loss 1.26, accuracy 64%, loss 1.0. So it's getting better on each cycle. Saving models, torch.save. We pass the model and we save it actually in a PTH file, which I don't know what stands that for. PTH. Once it's saved, we define a model and we load the file. And we can run some tests, like sending something, a test data, and then we can let it predict what the data is. So we're not actually sending the image file itself. We need to process the image in a way that it can be in a usable format for Pytorch, which the dataset and the data loader can do the job. So we can use that to send it to the Torch framework. and the model from Pytorch, the neural network model can use it. So it can be compatible, like having an abstraction on top of that. So I'm pretty sure there must be different kind of data sets and data loaders then. For each case, like files, PDFs, images, CSV files, JSON, whatever data. Okay, let's go. And let's have this in place. So let's define here. General overview, workflow. Let's say overview. So what is this? First, let's don't enumerate. Let's just say load the data. Load data, images in this case. How? Using data sets. Data sets. Train and test data. Fair enough. Then what? Then we load it. Then use data loaders to load the data. Understood. Then what? Create the model. Create or define actually the model using Pytorch neural network library. Just create it as it is, plus define GPU or CPU, whatever is going to be used for the training. Then optimize model parameters. Model params, which is training and testing. I hope this doesn't change that much over on my way to learn this. Okay, train and test. As part of the training, we load the data, we compute prediction error, we backpropagate, using optimizer functions. Then we that's it. And then we test. Test data load. Model evaluation. with what? We're still using the loss function. Loss function. Where we are using this? Okay, need to validate later. Then run some cycles or epochs. And train plus test, both of them. Then save model, load model, and have fun. Okay, really nice overview. So now we are going into tensors. What are tensors? Have we used tensors anyway? Yeah. As part of defining how to define the data sets and how to data load, we need to define the tensors. Tensor is not for data loading, it's for data setting. In order to use data sets, we need to define what tensor we are going to use. So when we talk about tensors, we talk about how to initialize, what are the attributes, what operations we can do with tensor, and some NumPy things. I think NumPy tensor is compatible with Pytorch tensor, as far as I know. Tensors are a specialized data structure, very similar to arrays and matrices. What? English matrices.
Cultural and social matrices, creating spaces for the play.
Matrices.
You can read more in my article using prioritization matrices on NM.
Matrices. Tensors are similar to NumPys and the arrays. Oh, it's multidimensional arrays. Multidimensional arrays. Except that tensors can run on GPUs or other hardware accelerators. In fact, tensors and NumPy arrays can often share the same underlying memory, eliminating the need to copy data. Wait, what? A bridge with NumPy. In fact, tensors and NumPy arrays can often share the same underlying memory, eliminating the need to copy data. So that's why we can share data between NumPy and tensors without having to load from scratch or from the beginning. Tensors are also optimized for automatic differentiation. If you're familiar with n-dimensional arrays, oh no. My ribs. Okay, it's Let's continue. Where was I? Tensors are optimized for automatic differentiation. Well, autograd, automatic differentiation. If you're familiar with NDRI arrays, you'll be right at home with the Tensor API. If not, follow along. Follow along. Yeah, okay, let's start from beginning because I don't get most of this. Okay, let's go everything and let's take some notes at the end. Tensors. Okay, initializing a tensor can be initialized in various ways. Okay, I need help on this one as well.
With your ears. And 1, 2, 3, Aquanetta, his mother, went through the various ways in which Ben could.
What? Various ways. Various ways.
We were just having a brief conversation of the various ways that you could protect.
Various ways. That's gonna be hard. That is gonna be hard. Tensors. How we initialize the data. So we use torch.tensor. And we send the arrays we want or we have. So if we have already, okay, from NumPy array, how to create a tensor. All right, it's gonna be the same. If we already have a NumPy array, then we can define a variable and just torch from NumPy, and we pass the argument, the NumPy array, and then we have a tensor. How to create a tensor from another tensor. The new tensor retains the properties like shape and data type of the argument tensor, unless explicitly overridden. No, that word doesn't exist. Over double D.
Do you ever get overridden by?
Overridden. So we have a tensor. Oh wow! We can create a tensor. X1's X data. One's like. Round like. What does this mean? We can create tensors by having another tensor and changing the data from the tensor. Like say it's a matrix. It's a matrix. We can change the data on the fly as we are creating the new tensor with random numbers or ones. I mean the number 1, yes, with a bunch of ones, with random or constant values. We have an array called shape. We create a random tensor, which is going to be random numbers. We create ones tensor, which is going to be full of ones. And we create a zeros tensor, which is going to be full of zeros. Random, I can see here. So we define the shape, which is going to be, I guess, the dimensions, right? 2, 3. What does that mean? 2, 3. 2.3 empty, nothing. I see these tensors have two arrays, each array with 3 elements. Number of arrays and number of elements of each array. Okay, enough on creation. Attributes. What properties have a tensor? The shape, data type. Oh, has to be one specific data type. Cannot be like many kind of data, different data in the data structure on each matrix. Device tensor is stored on. Nice. So we have the device, the data type, and the shape. Operations, what we can do with a tensor. Okay, we over 1,200 tensor operations. 1,200 tensor operations. Including arithmetic, linear algebra, manipulation, matrix manipulation like transposing, indexing, slicing, sampling, and more are comprehensively described here. Let's go. Ooh, now we have Pytorch documentation. Yeah, but what are the operations? Okay, math operations. Abs, absolute, arcos, arcos, add, mole, angle. Wait, what? Where are they? Is it really like 1,000 operations? Floor, gradient, lerp, log 10, log 2. Yeah, it looks like it is. Cool. Standard NumPy like indexing and slicing. A breeze to use. What is that? So it's showing up some NumPy like operations for indexing and slicing. With Tensor API is going to be breeze to use. What does that mean? Easy to use. Okay. Okay, let's see. Let's create a torch tensor. We print the tensor. We can have access to specific parts like index of the tensor. We print that array. First row, last column, first column, last column, first row, the entire tensor. Interesting. So what? First row, how we define the first row? So the first index, 0, because we have 4 here. The first column, okay, only first column. No, we can have access to the first column only. But how? The last column. So rows, columns. Pretty clear. Okay, joining tensors. You can use torch.cat to concatenate a sequence of tensors along a given dimension. So basically we can merge tensors. And then we have some arithmetic operations like transposition that returns the transpose of a tensor. What is matmul? matrix multiplication. Okay. So we can matrix multiplicate with a given tensor. What else? We can also do one-to-one multiplication. What is rand like? Touch move. We can multiply two tensors and have the output in a third tensor. So different ways of doing arithmetic operations with tensors. Single element tensors. We can aggregate the values of a tensor into one value. Like having like an average of the values of the tensor. In place operations, like increase, decrease each value. Bridge with NumPy. Tensors on CPU and NumPy arrays can share their underlying memory locations, and changing one will change the other. Oh, cool. If we have a tensor, we can send it to a NumPy. So Torch have this function called NumPy, which means if I have a tensor objects which call x, then x.numpy function will give me a numpy array of the same data, same memory location of the data, so I can keep operating with the data quickly and use all the NumPy benefits, which I don't know what it is, but NumPy seems to be really great and amazing. From NumPy, if I have something in NumPy, I can also convert it to a Pytorch tensor. And that's it. That's a really good overview on tensors. Okay, let's take some notes. Tensors. And the arrays. Can be... No. I don't think I actually need to set the values of my tensor with random numbers or just ones or zeros in a real case scenario, but let's take some notes. Some tensor functions. Zeros, ones, rand. Okay, a tensor, talking on properties. A tensor have shape, data type, which is D type, and device. Operations. We can merge or concatenate tensors. We can matmul, single element single element. In place operations. In place operations. NumPy will give a num and the array object is compatible. The other one is from NumPy. So we have a Pytorch tensor object. Okay, nice start. Pytorch, how to create a model, the overflow overview, the workflow overview. What is a tensor? The overview, properties of the tensor. Once we have the tensor defined, we can start using data sets and data loaders. So I'll keep on this tomorrow, but let me just quickly overview this. We load the data set. We define the data set, which is where is the data? Is it training or not? We want to download it or not? And what tensor or the transform? What's this transform? Okay, I don't see tensors yet here. Iterating and visualizing the data set so we can play around with the data set. Then we can create a custom data set for your files using pandas. So let's know a little bit of pandas as well. We are going to have fun tomorrow. It's gonna be really amazing. Custom image dataset, which another class. We define the labels, the transformer, how to get the item, the initialization. Okay, we define the custom data load, data set. Then we have to use the data with data loaders, and we have to iterate. That's it. Then transforms and etc. 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 Okay, we have this one. I didn't understand this. Nice. Now let's take a look on Django. We've been working on Django, right? So we've been working with Django. I need to do some labs because we were learning about models. I've been learning about models. Let's see. There's 3 Django models. So we have the ORM. We're gonna work this time with Postgres, and I'm going to set up that with Docker. We are going to run the database with Docker. We are going to create a project, the apps. We're going to play around with different model relationships. So we will be creating different models, and models have to have relationships. One-to-one, many-to-one, many-to-many. And then we need to play around with fields, char fields, text fields, data fields, datetime fields, Boolean fields. What else we have? a bunch of fields. We can even have custom fields. URI fields for URLs. So once the models are defined, the fields and the relationships all defined, we can start migrating the data so we can have the tables in database. And once that's in place, we can start playing around with the model objects. We can start creating objects, meaning we can just fire up a Django shell, call the objects, the models, and we start instantiating models, and we start creating and saving data in database. Or we can create the tests files. We can create tests, so then we can create models, verify the model is being saved, and run some asserts to validate that. So how to define a many-to-one using foreign key. How to define a many-to-many using the models many-to-many, many-to-many. One-to-one is one-to-one field. That is a field. Foreign key, many-to-many, one-to-one field. So once that is defined, we can start playing around. Well, and after we migrate the models in the database, we need to work with CRUD operation, which is create, read, update, delete. Create, update, delete is straightforward. The read is the thing where we can fetch data from database. And we have many options in there. First of all, the .get. The object that get can get a single object. We need to use the try and catch exception, the except option in Python, in order to make sure that we are not pulling more than one data. More than one result or row or object. Okay. Or in case we have no data as a result, we need to use an exception. We have the .all to get everything. We have the .filter, the .exclude, and the .order by methods to get the data we want. And we can chain these methods, and we can have multiple parameters on each of them. The .filter, the .exclude, the .order by. Okay, clear. So all of these three methods to get objects supports the lookups. So we can validate the strings, for example, and we can look for strings that contains something, or starts with, or ends with some suffix or prefix. And we use underscore, greater than or equal than, lower than or equal than. We have lookups for strings, for dates. We can even have lookups for model relationship queries, saying that we want to find a particular attribute or characteristic in the objects that belongs to another object. So we can use lookups for that, more complex lookups. And we also the query objects, the query object where we can add more booleans and more complex queries to get the data we want. And on top of that, we can even have aggregations. So we can annotate this thing and aggregate data. So we can process the information, the result information on the SQL side, I mean on the database side. Like having average, like adding up all the numbers, doing sums, I mean, all the aggregations. So I need to see examples. And I remember I had some already. Let's see if it's still there or they just got deleted. They got deleted. Django models. I have some examples. Let's use a stack edit. Let's copy paste this. Oh, I have some data here. I have something here. Okay, let's start from the beginning. Some examples. So we are going to start the project, start the app. Then we create some models using data fields like chart field, date field, text field, datetime field. We can define how to do the default ordering for whenever we get data from this class. And the default ordering here is gonna be name, one particular column. Okay, we have the author model, we have the publisher model, we have the category model, no relationship so far, and we have the book module that has no relationships now. Well, the book model has a bunch of different fields, Boolean fields, positive integer fields, and then we have relationships. Foreign key, which is the one-to-one or not. This is the many-to-one, meaning that one author can have many books. But this particular book is going to belong to one single author. Is that right? Publisher, yes. Can the book have many publishers? Many authors, and the author can have many books? That makes sense. But I mean, both are okay, unless you have some restrictions due to the contracts. Let's say the book only belongs to one single author and only belongs to one single publisher and can have many categories. That's why we have many fields. Created that, updated that, some metadata information of the class meta. Then we have the customer class, which is the user. We have a rental class, meaning this is kind of a library application where we can rent or lend books to people. So the rental needs to have the book. So we have a foreign key. Our rental has one particular book, but a rental actually can be like multiple books. A person can ask lending of many books in a row. I will need to test myself this. We have the customer, which is a foreign key. Yeah, that's okay. Usually one single person can ask for the renting or the lending of a book, not two persons for one book. That doesn't make sense. And we have some options, methods. It's overdue. We have the save method where we can, what's this for? Super. Oh, it is inheriting another class. Well, yeah, the main class, yes. But it's checking if it is overdue and the status is not overdue, then the status will be overdue. And the overdue function is validating the return due date and the time zone now difference. If they are different, one is measured than the other, then the book is in overdue state. The rental object is in overdue state. We have reviews. This will be for a web page. Reviews, a book, customer, rating, comment, and the creation of the comments. Okay, that's a bunch of models that can be used. Then we can start migrating and creating those, applying migrations. We can have a custom migration that I don't care yet. Then we got into shell, Django shell. We do some CRUD operations. Let's see how to pronounce this. CRUD operations. CRUD operations.
Somewhere, and we want to be able to do the standard CRUD operations, or you'll see there, I actually...
CRUD, yeah, that is the CRUD operations. It's raining. Ouch. CRUD operations. So you're using the shell, but you're writing like a script in there. Okay, you import the models, you use the time zone library from Django and the datetime library from the Python built-in library. We create the author, we create a publisher, we create categories, objects, and finally we create a book. Okay? Then we add many-to-many relationships, which is book.categories.add. So we start adding the many-to-many relationships. We create a customer, we create a rental, we create a review. We are creating, and creating. Then we do the read operations. Book.objects.get, and we specify we want what column to filter in order to get something, or the primary key. We can change a property and do the .save to update the object. We can filter some objects, like doing we can filter a bunch of the books and chain a function method which is update if we want, and we can change a particular value. So we are getting and updating at the same time in one single line. We can delete a particular object by calling the delete function, or the same as update. We can get a bunch of objects using the filter function, and we can chain the delete function to delete those objects. So that is reading, fetching from database. Now we can query and we can filter. So we already started using the filter, but now we are using the lookups underscore underscore GT, which is greater than underscore underscore year, and we specify the year. And we can chain multiple filters functions, multiple filter methods, and pass different options. We have the exclude, how to use the OR queries using the Q object. Pipe 1% to say or and condition. We can use the not operator, the like queries, which is basically the lookup for the strings, where we can specify underscore underscore contains or I contains, starts with, ends with, or I starts with, I ends with, for sensitive case strings. In queries for arrays. Range of numbers, in range of dates, checking if it's null or not. Date queries, this is my nemesis. Dates in Python. Time zone, daytime. Complex queries and aggregations. Wow. Yeah. Book that objects that aggregate. And we can use average, max, sum of one particular column. Okay, this is annotations. You don't know what this is. Calculate the average rating for each book. So this is kind of doing SQL, but in a nice way. In a nice way. Annotate, and we are using the filter and lookups. We are using the average and annotating. That's really complex queries here, which seems to be amazing. We can dot values. What's this? Querying with subqueries? Querying with subqueries. Wow. And we also support, it also supports raw queries. That is useful because when you're working with it, usually you go to your SQL IDE to start getting data by yourself, and you can basically use the same queries with other compatible SQL syntax engines. So you just won't be able to do the same with Python to other syntax. You can just copy paste your SQL queries. So that's gonna be my dilemma. Not dilemma.
Tough choice. But the real moral dilemma is accidents are happening.
Dilemma. Yeah, that's gonna be the thing. Do we use raw SQL queries or do we use Django complex queries? Which one is gonna be maintainable in a long-term basis? I guess, yeah, no other options. We have to use both of them. Advanced model operations, that's bulk creates, bulk updates. Select related, what is this? Combine select related and prefetch related. What the custom model methods? Oh yeah, model methods. Yeah, well, that's pretty much clear. Oh, we can have, well, it's talking about transactions. Yeah, that's rollbacks and transactions. admin interface. So how to define the admin interface? We have to register the classes into the admin application, Django admin application. We can define some how to display the columns, which columns to be displayed, which ones are going to be a search field, auto completion, read-only fields, how to organize field sets so we can group by something the fields on the model, so we can have a nice form to edit or create an object. Customer admin. Okay, and we have testing. We can start testing this app using the test case from Django test. And we can use asserts to validate something is expected or not. This works for, it basically compares left and right values. Assert equal, assert is not known, assert not equal, I guess. Asserts, that's all we need. A bunch of assets. Signals, I don't know what it is, I don't care. Advanced model features, custom manager, new releases. Okay, this is the queries. These are the queries, predefined queries that I can use on if I don't want to have a really messy chain of filter methods, exclude methods, or order by methods. I can have it already in one single place, and that is my custom manager class. Abstract models, proxy models, model inheritance, or ORMs in views. Okay, this, wow, it's a lot of code. I'm having a deja vu. So that's Django. That is Django. So the other day I've been reading about reactjs. Learn Reacts. Yes. Let's quickly learn. We saw how to create a component. We saw we have handlers for events. Each component can have one. We have seen CSS, hooks. Oh yeah, well, we can have kind of global variables that can be used across multiple components. The use states to remember data. It is kind of storage mechanism, which where the local storage is being used, I guess, in the web browser, local storage. So we saw here last time how we can create the tic-tac-toe game. And we saw that it was doing step by step. So pretty much it's repeating itself, how to create one particular component, and it's returning the HTML code, right? And that the code can be repeated in a way that we can invoke the component multiple times. We have a root component which is going to call the other reactjs components. Kind of a embedded components. Components can have data. Okay, let's see. We are seeing more and more examples. We have this templating system where the component is expecting a value that can be rendered in HTML. So that value is going to come from outside. When invoking the component, we have to pass something, the data, the object, I guess. In using templates, we can replace those with variables. The component also can listen events. We define the function events inside of the function of the components. Okay, clear enough. Each component can also have its own use state functionality to remember data. Fair enough. Whenever we need, we can update the use state and set the right values we want. Yeah, we are seeing events. Events are really messy. I guess because it's JavaScript. I guess if it is TypeScript, it's gonna be more easy to understand, I guess. I hope. I'm seeing some rules that I don't think I will remember. Why immutability is important? I don't know. I honestly don't know. I don't want to know. I'm sleepy. I want to sleep now right now. Declaring a winner, okay? This is the tic-tac-toe game. It has some other functions to do some calculations because it's a game. So it's doing the game logic and it is also doing the game rendering. It's also handling the events because I need to point and click. So that is an event that needs to do something, to trigger something. So I'm seeing rendering, I'm seeing logic in place. So this is talking about how to call a React component. And it mostly seems to be more JavaScript tutorial. Maps, use states, more functions that are related to events, the on-click event, getting more complex, possible errors, array errors. So yeah, it's JavaScript. But what about React? What about state? What about routing URLs, templating? I'm just seeing JavaScript. Story. Arrays, that's arrays. Final cleanup. Then some variables, assignations, operation, that's JavaScript. No need to exactly know that because my application can be a little bit different. but maybe it's worth to know it. Okay, let's see. This is the complete example. We have just one single JS script, which has everything. We have the square component. We have the board component, which is the most complex. Have one handle click for event. Have calculate winner function, not a handler, just a function to calculate winner, a logical function, and the return of HTML stuff. It has the game components, which has states in there, handle play, which I guess is an event, jump to, it's gonna be an event. We have a data call, a map that's gonna store data, and the return, which returns HTML. It returns, okay. And finally, we have the last return that is returning HTML and some React components, the board only. Then finally here I see the calculate winner like a function. It seems to be like a global function that can be accessed from anywhere. And that's it. Thinking in React. Okay, do I need to think? Start with the mockup. The mockup looks like this. Break the UI into component hierarchy. Yeah, that's really important to know, to abstract how the application, the web application UI is gonna be represented in a directory tree or project layout. So we don't have one single big file for everything. The components as well. What components gonna have? Which ones are gonna be reused? So it's not actually thinking, rather architecting or designing or laying out the project, not thinking itself, thinking. So once I have this, what's next? Installation. How to install? Try React. Creating React. If you want to start a new React application, you can create a React app using the recommended framework. Creating a React application. Okay, now we are talking. Now I'm seeing some commands. So now we are starting from the beginning. The other beginning was not actually the beginning, it was like an introduction. That was the quick start. So I'm left in thinking on React. Okay, that's where I'm letting this. So we've been doing Pytorch, Django, React. Now I need to finish and wrap it up with AWS S3. What was the last thing? Pytorch S3, identity access, okay. Preferences, dark. Access control, this is amazing. Identity access management, what? IAM. So what we will learn here? IAM, request authorization, how it works, permissions, API permission, operations, policies and permissions, bucket policies, identity-based policies, workflows using policies. linked roles, storage lengths, troubleshooting, managed policies. Pretty fair enough. Fair enough. Audience? What do you mean? Audience. Isn't this manual tutorial for me? How you use AWS Identity Access Management differs depending on the work that you do in Amazon S3. You can be a service user, service administrator, AAM administrator. Oh, nice. I love that. Okay. If you use the Amazon S3 service to do your job, then your administrator provides you with the credentials and permissions you need. Okay. Service administrator. If you are in charge of S3, like you are a architect, DevOps, a killer DevOps engineer, a cloud engineer, you have full access to Amazon S3. IAM administrator. If you are IAM administrator, you might want to learn details about how you can provide policies, blah, 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 blah. Authenticating with identities. Okay. So this seems to be something more for IAM actually. If you are user, service user, admin, the root user, federated user identity, it talks about users and groups, roles. I mean, that's IAM. Not interested. Policies, identity policies. Identity policies can be further categorized as inline policies or managed policies, resource-based policies, access control lists, other policy types, permissions, boundaries, service control policies for AWS organizations, resource controls policies, that's new, RCPs. You can have a set of maximum available permissions, session policies. Okay. Seems more than AAM thing. Not S3. Not interested. How Amazon S3 works with AAM. Before you use IAM to manage access to Amazon S3, learn what IAM features are available to use with S3. Okay, from IAM world, we have identity-based policies. Supported by S3? Yes. Okay, just for the sake of learning more of AAM, let's take notes. Identity-based policies, resource-based policies, policy actions, policy resources, policy conditions, ACLs, ABAC, temporary credentials, forward access sessions, service roles, service linked roles. What? Are you serious? So what's your take on identity-based policies? You just have 2 paragraphs, no examples. So what do you say? Supports identity-based policies? Yes. Identity-based policies are JSON permissions, policy document that you can attach to an identity such as an IAM user, group of users, or role. These policies control what actions our users can perform on which resources and under what conditions. To learn more, click here. With AAM identity-based policies, you can specify allowed or deny actions and resources as well as the conditions under which actions are allowed or denied. You can't specify the principle in an identity-based policy because it applies to the user or role to which it is attached. To learn about all of the elements you can use in JSON, click here. Identity-based policy examples for Amazon S3, click here. Seems interesting. Honestly, more related to AAM, but really worth to understand. Really worth to understand. So it can be much easier for me then to learn AAM. Pretty sure AAM is gonna be crazy, but I'm starting already. So last time I said identity access management. Let's take some general review. Let's start with just this one and let's go. Identity-based policies. Identity-based policies. What's this? User groups roles, no principles. No principles. Okay, that's it. Okay, I have more, but I need to go. I'm tired. I've been almost 2 hours already. Time to go sleep. Let's go.